In this lesson, we continue discussing pattern evaluation. We will go over null-invariant measures and compare different interestingness measures. To understand the composition of an invariant measure, the key is to convert support of A and B to a conditional probability by dividing by either support of A or support of B. So if we divide support of A and B by support of A, we'll get the conditional probability of B given A. Similarly, if we divide it by support of B, we get the probability of A given B. Now, P and Q are null-invariant, which means any function of P and Q that maintains null invariance will also going to be null invariant. Examples are taking the minimum of P and Q, the maximum, the mean. All of these measures are going to be null invariant. We will study 5 null invariant measures that are all functions of P and Q. AllConf measures how strongly A and B occur together relative to the more frequent item. Pay attention how it divides by max support of A or support of B, which means higher AllConf, closer to 1, means A and B frequently appear together and rarely separately. Let's jump to MaxConf, which measures the stronger directional confidence between A may lead to B or B may lead to A, which means higher MaxConf means at least one direction has a strong association. Jaccard quantifies the degree of the overlap between two items A and B, intersection divided by the union. Cosine is the geometric mean and Kulczynski is the arithmetic mean. For the following example, we are interested in studying the behavior of the interestingness measures we just studied using the example of the association between milk and coffee. Suppose we have this contingency table which represents milk not milk, coffee not coffee, and 6 data sets. So each row in this table is going to represent one instance of this contingency table. Let's take a look at dataset 1 and dataset 2. We have identical MC, not MCC, M, not C, but different number of null transactions, not M, not C. It's very clear how chi-square and left significantly dropped once the number of null transaction dropped. So in other words, left and chi-square will significantly go up and down based on the value of the null transactions, which is something that is not good. Next, we will study the behavior of the null invariant measures we just overviewed. And for dataset D1 and D2, where we varied the number of null transactions from 100,000 to 100, the value of these measures did not change because the null transaction does not play into these formulas. So null transactions do not change the value of null invariant measures. For datasets D4, D5, D6, we fixed the values of milk and coffee, then varied the distribution for not milk, coffee, milk, not coffee, to observe the behavior of the null invariant measures. And I copied the table here so we can see the formula and make sense what is going on with these numbers. Kulczynski remains steady because the arithmetic mean of P and Q. Cosine goes down because it's the geometric mean of individual support values. So in other words, if support of A or support of B disproportionately decreases, it will take down the value. Jaccard also goes down if the skew is increased, and this happens because Jaccard is based on the ratio between the intersection and the union. AllConf decreases because it measures the confidence relative to the larger category, and max confidence remains relatively high because it captures the best case confidence. Now, given this experiment and the measures that we have, which one is better? It looks like Kulk is a promising measure because it remained constant across different datasets, but there's still a small problem with that. It didn't capture the changes in the distribution, not MC and M not C. In other words, it has become too robust. It doesn't respond dynamically to shifts in data composition. So that's why we need an additional complementary measure in addition to the Kulk. So we can look at two numbers at the same time. Imbalance ratio quantifies the imbalance between two items. It's defined as the absolute difference between how often A and B appear in the dataset divided by the total number of occurrences of A or B. Notice how support of A and B is subtracted to avoid double counting. Now we can read Kulk and IR together. You can say that D4 is neutral by looking at Kulczynski and its balance because IR is 0. D5 is neutral but imbalanced. Then D6 is neutral but very, very imbalanced with 0.99 for IR. A last word, null values or null transactions are going to appear in large datasets. That's why we need to deploy null-invariant interestingness measures. In summary, we discussed pattern evaluation, where we focused on null-invariant measures.